Good afternoon, everyone. Thank you for joining our webinar. My name is Emma Church. I'm here representing the HeatSource project on behalf of Built Environment Smarter Transformation. Welcome to our webinar on geothermal energy and underground thermal energy storage. And for those of you that don't know, HeatSource is a platform that we deliver on behalf of Scotland's enterprise agencies to bring together the clean heat industry and supply chain to understand challenges and opportunities and raise awareness of different technologies through networking and other events like this one today. So today we're going to hear from 4 fantastic speakers. We've got Vanessa, who is the Science and Operations Lead for the UK Geoenergy Observatory in Glasgow, focusing on understanding mine water heating and underground thermal energy storage potential in Scotland. And then we'll hear from Jamie McFarlane from the Energy Statistics team within the Office of the Chief Economic Advisor at Scottish Government. And he was key part of the production of the Scotland heat map, which we will have a live demo of today. And then we'll hear from Zoe Shipton, Professor of Geological Engineering at the University of Strathclyde and co-lead of the Decarbonising Heat team within the Scottish Research Alliance for Energy, Homes and Livelihoods. And last but not least, we'll hear from Rachel McCaw from Scottish Enterprise, specialist within the Energy Transition team, focusing on geothermal, data and digital technologies. We will have a couple of polls throughout our time today, so it's an opportunity for you to for us to learn a little bit about you as the audience, but also you have the opportunity to engage with our speakers. So please use the chat box that you will see. You can toggle to that in your control panel and ask our our speakers any questions. We will get through as many as possible, and any that we don't get to, we will answer in our post-event email, which we will also circulate all of the slides from today, so no need to take furious notes. We will also have lots of links, so any projects or resources or contact details that are mentioned throughout the presentations, they will be populated in that chat box as well, so you'll be able to click on the links from there. But again, they will be shared after the event as well. So thank you very much again for joining us. We'll hear from our first speaker now. Please welcome Vanessa.
Hello everyone. So the main aim of my talk today is to introduce the concept of underground thermal energy storage and focus really on ways that we could progress this technology within the UK. Could I have the next slide, please? I'm also going to provide some information to you about an upcoming workshop to which you're all invited. So sorry, that should be the next slide. Yeah, thank you, Rich. Okay, but before I move into the discussion about underground thermal energy storage, I just want to give you a quick overview of geothermal energy. Next slide, please. So geothermal is heat from the earth, and as we're all aware, the temperature increases as you go down in depth. So the 3 maps that I'm showing, they actually represent slightly different types of geothermal energy. We have on the right, as you're looking at it, potential deep geothermal opportunities. Now, there isn't an absolute depth where we go between shallow and deep, but in general, any deep geothermal is where you can use the heat directly, either to heat a building or to, in some cases, actually have power generation. And you can see that there is a lot of potential across the majority of the UK. But focusing more on the shallow geothermal, because this is really where my talk is leading, I have a couple of maps here. The first one is showing mine water geothermal. So shallow, by shallow, I'm talking really things that are less than 500 meters. But again, this is where we have temperatures that are low enthalpy, around 10 to 20 degrees in times. In order to get the temperature that we need, there is a requirement for a heat pump. One method that we can extract heat, we can either do it directly from a rock, or we can do it from old abandoned mines. So these mines, over time, they've become flooded, and we're able to, by circulating the water, extract the heat from the mines that are below the ground. Now, my multi-geothermal is a proven and it actually is operating. There are at least 6 operating schemes in the UK that are happening today. And as I mentioned, we needed to have a number of heat pumps. So if you were just to take a single borehole and put in a heat exchanger, then you still need a heat pump to boost up the temperature. And you can see, again, this is very proven in the UK, and there's over 55,000 of these heat pumps installed at present day. Now, there are concerns with geothermal energy, there are issues, there's still a lot of unknowns, and there's still a lot of policy work to be done. But I'm not going to focus on that today. Instead, I'm going to move on to underground thermal energy storage. So on the next slide, you'll start to see the principles behind the underground thermal energy storage. So basically, you can think of it as almost being the opposite of geothermal. In geothermal, this is where we want to extract heat from the ground. And you can see that on the heating side, we've got the warmer temperatures down under the ground. You can use an abstraction borehole. This is an open loop system here, where you can abstract the water, you can take the heat out using a heat exchanger, boost it up using a heat pump, and then heat your building. And then the cooled water is returned down into the subsurface. But underground thermal energy storage works in the opposite way. It takes heat from the atmosphere or from maybe a building that generates a lot of heat, like a data center. That heat is captured, goes back through the heat exchanger, and is put down into the ground. So you could think of the ground really acting like a large thermal battery. In the meantime, we are now extracting the cooled water, which then goes up into the building, and that provides cooling. Now, if you look at these two schemes in conjunction, I think you can start to see how powerful it is. So in times where we have got heat or we've got excess heat, we can put the heat into the ground where it can be stored. But then in times where we need the heat, we can abstract the heat from the ground and use it in buildings. So this starts to balance our energy demand. We can do this seasonally, such as the examples that you can see on that little diagram, or we can do it on a daily basis, or we can do it in whatever demand scenarios are most used across a variety of points, such as local councils. UTES, or underground thermal energy storage, is also very efficient. So it does increase the sustainability. There is always a slight concern, how large is the resource? It's much larger than just around the borehole, but there is still a lot of work to be done to understand how long, what is the sustainability of a geothermal scheme. But by putting heat back in, that just increases the sustainability. There's less environmental impact on the actual subsurface. You're not going to be producing extreme temperatures in terms of change down in the subsurface, because you can start to balance out the temperatures. And I believe that there's a better heat pump performance, but I don't have the data to back that up. So if UTES is so important, why are there so few schemes? And at the moment, I believe there's around 20 schemes that are in operation within the UK. Now, that is not the case in some of our neighbouring European countries. For example, in the Netherlands, there are hundreds of thermal energy storage schemes. So again, it is proven, but the uptake in the UK is relatively low. So on the next slide, I'd like to show you that there are many reasons why shallow underground thermal energy storage has not been widely adopted at this point in time. Now, the slide, the circle is quite complex, but it starts off by showing that in the centre, we have still some unknowns about the actual processes. How does the heat disperse? What effect does it have on the microbiology? Quite research-based questions. Moving out though to the next slide, you can also see that there is an operational uncertainty. We need to have people who are trained in using it. How effective can these schemes be? How big should my scheme be? Those are just questions that are sitting in the operational area. And then in the final one, which we've classified as implementation, still need to get acceptance. The government needs to be accepting of it. There needs to be policy, there needs to be regulation, and there needs to obviously be social acceptance. So I picked a few barriers that I put on the right, And you can see that most of them is what I've just talked through. The one that we're really focusing on today and that the British Geological Survey are most able to perhaps assist with is the resource characterisation. So these are questions relating to sustainability. There's obviously a question, if you put heat into the ground, does it disperse? How much heat can I get back at a later date? What happens if there's two systems that are built right next to each other? Are we going to be pulling on each other? Now, the answer to all of these barriers, there is one point that really stands out to me, and that is that we need more data. Now, by data, it could be lessons learned from operating schemes, it could be collaboration with other people, but to progress, we need to get data. Another way of getting that is to use some of our fantastic laboratories that we have both in the UK and in Europe. Just briefly on the other one, as you might have noticed, the other point that I brought up was collaboration. That is equally important to data. And that is really why I'm very keen to spread the word really about underground thermal energy storage, because we can only progress if we understand the concerns and the risks that each part of the actual progress has. So consolidation and collaboration is highly important. But briefly coming back now to two of the laboratories. So I mentioned we have a need for data, and we can do that through, as I mentioned, operating schemes. But I'd like to introduce you to two BGS operated facilities, and these are known as the UK Geoenergy Observatories. The first scheme that we have is based in Glasgow. It's very close to Celtic Park and to the Commonwealth Games Village. It's built in the Cunningar Loop within the park, and as you can see on the picture, there is a meander belt and the park sits within the River Clyde meander. It's a beautiful location. And in that observatory, we have an at-scale research and innovation infrastructure, both for mine water geothermal, but also for mine water energy storage. And this is very typical environment for where you can put these schemes very much in an urban environment. Our second observatory is the Cheshire Observatory in the northwest of England. But this one has a slightly different focus. This one is focusing on the aquifer geothermal and the aquifer thermal energy storage. So this is really from rock, not from mine water. This is being built, there's about 21 boreholes, 100 metres in depth, and they access the Sherwood Sandstone aquifer. Now, this one is designed to understand in great detail the thermal and fluid flow paths through a particular piece of rock. So moving on and coming back now to focus on the Glasgow Observatory, I'd like to discuss in a little bit more detail a couple of the results. So the Glasgow Observatory infrastructure, it has a number of boreholes. There's 12 in total, of which 4 of them are linked into the geothermal mine water scheme. They access 2 different levels of mine workings, the Glasgow Upper around 45 metres and the Glasgow Main around 85 metres. The boreholes are fastened by a linkage of pipework into a heat centre, and within that heat centre there are 3 different heat exchangers. So very similar to the diagram that I showed earlier, you can abstract water from the mines and then you can bring it through the heat centre, through the heat exchanger, and at that point you can either extract the heat or you can put the heat back in. And that is because we have on the site a large heat pump chiller, and this can be run in either mode. So it can either extract heat from the atmosphere or from a particular storage piece of equipment if that is brought to site, or it can dissipate heat. So the site can be run in either direction. We have a number of sensors across the whole of the site, but what I want to focus on the left, a couple of examples, are the fibre optics. So we have direct temperature sensing fibre optics installed in every one of the boreholes that is penetrating in the mines. And what this enables us to do is to map and monitor changes in temperature along the borehole. So what you're looking at in the top picture, unfortunately I can't point to this very clearly, is one of our boreholes, and this is our injection borehole, GGA01. It goes into our Glasgow upper. And when we turned the pumps on, in this case, we were extracting heat. So we were not doing the thermal storage, we were extracting in a normal, more conventional geothermal method. But you can see that very dark blue line at the bottom at about 45 meters. That is representing the screen section of the mine working. And you can see that we have put this cold water, where the heat is being taken out, back into this mine. Where you see the dotted line that says end of experiment, this is the part where we have stopped pumping. We've stopped putting any more cool water into the mine working. And you can start to clearly see that it is beginning to re-equilibrate back to baseline. And what this will allow us to do is to determine what is the length of time, or in other words, how much heat can be stored in that area before it disperses. This bottom one, GGA02, that's a different borehole. It's about 5 meters apart on the same side. And what this is showing is that you can see how the thermal plume starts to move. And this will give an indication of how the thermal plume develops. We've got 3D sort of appearance when we start looking at it across the whole site. And so we can work out, where is the heat going? How long does it stay? All questions that we talked about earlier for both our understanding of the geothermal, but also the thermal energy storage. Moving on to the Cheshire Observatory infrastructure, this one has got 21 boreholes. They're in a very tightly spaced. We've got 24-meter site by about 24 meters. So it's a very small space, but it has 21 boreholes in here. So we are being able to look in great detail of how thermal plumes and how fluid moves through this particular rock. Remembering we're looking here at pore spaces and fractures. A very similar experiment can be undertaken, although there's many others we could also do at this site. But if you start to re-inject the water into the re-injection well and abstract from the other one, and then put a thermal plume on the boreholes between, you can start to map where preferentially the thermal plume goes. And the next slide shows some real data that we've collected from a test. And what you can start to see here is, again, with the color scheme, it's quite close, but you can start to see that the thermal breakthrough, or the thermal plumes, are following the fractures. So what this could indicate is that you might not want to put your energy storage scheme where you've got very large fractures, because that may be where your heat starts to move very rapidly away from your area of storage. So I'm aware now I've got 2 to 3 minutes remaining, so I'd like to just come back on the next slide to the invitation that I mentioned right at the very start. So I would like to extend an invitation to everyone to join a workshop that BGS is planning to hold in March. I'm going to be focusing in that workshop on the efficiency and the sustainability of underground thermal energy storage. So there's a number of example topics and questions that I have referred to as I've gone through the talk, but you can see, for example, how does the type of rock or mine working control heat recovery? How fast or far does it travel? Most importantly, how much can you recover if you put heat in? How much can you get back? Does the rock type, does the mine working, do they affect it? Can I keep doing it? What are my demand scenarios that we're trying to match? Can we match it? And then obviously it leads through into regulations and permitting. It leads through into the business case, the savings, because at the end of the day, we do need to get improved efficiency and cost reductions compared to just doing heating alone. So the final slide that I have provides, oh no, it's not my final one, sorry. So the main aim of this workshop is to look and define some of the research ideas that we could aid the uptake of UTES. So we will get more of these schemes across the country. It's really important that we get a range of different stakeholders. I mentioned earlier how important collaboration is going to be. We need to understand what local authorities' demand scenarios look like. We need to understand how heat pumps manufacturers want to be involved, and we need to understand the regulations and the policyholders' requirements. So within that workshop, we'd like to have a range of people, we'd like to explore these research ideas, and we'd like to think about how we can use the observatories or other data to provide at-scale data to feed into these questions. The overall aim would be to lead into a research and innovation consortium. So there will also be a chance to discuss that in more detail, what people would be interested in. So if you are interested in participating, I would like it if you could please email me. You can see the contact there. That will get directly through to the UK GEOS team. Remember, all groups are invited to attend. And if you have stated that you're happy to be contacted, then we will probably be in touch with you anyway. But please, even if you've got an interest in it, let us know so that we can incorporate you and involve you at least in the planning. Thank you very much. If there are any questions, I believe that we've got a session at the end after the other speakers. But right now, I'd like to pass over to Jamie McFarlane.
Fantastic, thank you. Just before we head over to Jamie, we've got everyone that's all of our attendees have joined now, so we would like to do a short poll with you. It'll come up on your screen shortly, just to find out a little bit about our audience today. So if you could please select which best describes your organisation. So industry, organisation, academia, public sector, support organisation, or other that can't quite be defined by those. So please please make your selection. It will only be available for about 30 seconds or so. That'd be really helpful, thank you. Excellent. Thank you very much. Appreciate that, everybody. Like I say, next up, we have Jamie McFarlane from Scottish Government, who's going to talk all things Scotland's heat map.
Hi there. Yeah, I'm Jamie McFarlane. I work as a statistician in the Energy Statistics team at the Scottish Government. So I'm going to be giving you a bit of an overview of the Scotland heat map and some of the geothermal information which is included. So if we could just move on to the, and I'll hopefully be able to give you a short demo of the website as well, technology dependent. So just to give a bit of background on the heat map, it was created in 2014 and we've had a number of iterations since then, and tries to bring together data from a range of sources, from Ordnance Survey to EPC information, energy saving trust modelling, to try and estimate the heat demand of every property in Scotland, including domestic and non-domestic. And then in addition to that, we also include several other layers to supplement that and allow a spatial analysis and visualization, so that this can be used in energy planning. So it's a key data source for local authorities to produce their local heat and energy efficiency strategies and delivery plans. But so it's open, it's available to the public sector, and we also have a more detailed version which we provide to local authorities, and then we also have a public facing version which doesn't quite go down to the property level, so it's slightly more aggregated, but does include a lot of the information that is in the heat map. And then just to say as well that it's obviously we're trying to make our best estimates of heat demand and bring together all the data, but it is an indicative tool, so it's there to assist, but it's not the sole basis for decisions. It can give an indication of where they might want to target some of their efforts, and then kind of go on to do more in-depth and detailed analysis. So we used to update the heat map on an annual basis, but we've recently moved to a 3-year, 2-year cycle, and so that's kind of to align with the LHE's updates, which can be updated every 5 years. And so we released the latest version of the heat map around a year ago. And so our next update is going to be in 2026 with that date to be confirmed. So I'll just move on to describe some of the geothermal data which is included in the heat map. So there's several different layers, and the British Geological Survey datasets that are in there are based on a 2013 study, which they carried out on behalf of the Scottish Government with AECOM. So we've got several layers noted there. And then there's also several layers from the Mining Remediation Authority, which give an indication of some of the coal mining areas. And then the final thing which I was going to mention is the Improvement Service have published a web map of the mine water geothermal resource atlas, which is based on some PhD research by David Walls, and that's looking at the most optimal locations for that. So it goes into a bit more detail than the datasets which are on the heat map itself. So I thought I'd include that link to there. It's not actually in the heat map, but it's another potentially useful resource of data which is openly available. And then all of the metadata for the web version of the heat map is on the spatialdata.gov.scot website. So that's a catalogue of spatial data which is published by public sector organisations in Scotland. And so yeah, it's got all the background data and metadata for the heat map, and also includes the API links for the web feature services and web mapping services, so the data can be added to your own GIS maps as well. And then, so I think we'll move on to hopefully be able to give you just a very quick demo of the publicly available website. So hopefully my screen should be getting shared now. So yeah, this is the heat map website. So initially, yeah, you can, once you click get started, you can see the range of different layers which are available on the heat map. So the heat demand is selected initially, and this is at a 1 kilometre grid scale, but the web version of the map does go down to a 50-metre grid, and then you can zoom in. So I'll zoom into Edinburgh to show you that, and so you can see, yeah, that mapping feature there, and then just to give you a little bit of a demo of the geothermal data. So you can see the data sets that were mentioned in the slides. So we've got the depth of abandoned mine workings there, and the other ones, and the 4 that are greyed out at the bottom here, those are only visible at certain resolutions. So as you zoom in a little bit further, these then become available, and you can see those. And then the final thing which I'll show you, so the arrows on the right hand side, if you click through, it's got a short description of each data set, and you can then click through to the spatialdata.gov.scot website, where you can find out the full metadata and background on each of the data sets and the web mapping services and web feature services if they're available as well. And then there is a few other tools, so you can reset the map at the top, but you can also print or take screenshots of the website, and you can also select custom areas as well and create reports and links to specific maps, which you've, depending on which of the layers that you've selected. So wrap up there and pass back. Just stop sharing my screen now. So pass on to Professor Zoe Shipton.
Thanks very much, Jamie. That's a really interesting resource, and I really encourage people to go and have a look and just play around and see what opportunities there are beneath your community or beneath the land that you own. I'm here to present a couple of ongoing research projects. One that's hosted at the University of Strathclyde and one that's hosted by a company called Townrock Energy in collaboration with the University of Edinburgh and a huge number of other people. So the first project I want to talk about is one that I lead at Strathclyde called STEAM. And with STEAM, we're looking at whether we can use mine shafts, legacy mine shafts that were abandoned and capped off when the coal mines were abandoned. This is the Barony A-frame in Ayrshire that overlies a shaft that goes down to 600 metres deep. It contains 21 million litres of water. So the question we're trying to answer in our research is, can we use abandoned mine shafts to store energy? There are 130 odd thousand mine shafts in the UK. There's coal mines beneath 25% of British households. There's only one of our 10 biggest cities is not underlain by coal mines, and that's London. These mine shafts are various different sizes. Some of them are very shallow, but the big ones are the more modern shafts that were going through rocks, hundreds of meters of rocks, up to 1 kilometre down to extract the rocks from the really deep coal mines. Could store millions of litres of volume of water, and that could give you gigawatt hours of energy storage. So if we can use 1% of these mine entries for heat storage, we could supply 10% of UK homes in what's known as a worst case weather week, when there's really cold weather and no wind, which is what we've been having recently. That 10% figure is predicated on us being able to heat the water in the mine up to 55 degrees C. So we don't need a heat pump. As Vanessa said at the start, if you have cooler water, you can upgrade the heat with a heat pump. But if you can get water at 55 degrees, you can use that directly into a district heat network. So if we can go on to the next slide. One of my PhD students, Catherine Deeming, has recently had a paper accepted for publication looking at the scale of the opportunity in Scotland. So in the left-hand map here, we can see orange dots, which are all mine shafts that are over 50 metres deep within the central belt of Scotland. Those grey blobs are the coal mining areas that the Mining Remediation Authority defines. The ones on the right are mine shafts that are within 1 kilometre of an energy from waste plant, HeatSource. And the one on the very far right, just south of Edinburgh, is the Miller Hill Energy from Waste plant. And within a few tens of metres of the Miller Hill Energy from Waste plant is the Monkston Hall #2 shaft, which is what is the focus of the STEAM project. So we can go to the next slide, please. So what we're trying to do in STEAM is really answer the question that I posed at the start. Can we use 1% of the mine shafts? Can we take it to 55 degrees safely? So the questions, we're conducting an assay of the national asset of mine shafts and checking whether 1% is a reasonable number in terms of depth and the state of the shafts. The Mine Remediation Authority holds all the archives on abandoned mines, including the plans of the mine workings and information on the construction and abandonment of the shafts. But those archives you have to search them one by one. They're not in a big unified database. So we're doing that work for you, and we'll be publishing as much information as we can, so that if you have one of the mine shafts in your back garden, as it were, you'll be able to find out whether that's suitable for storage, or whether we don't know yet if it's suitable for storage and more work is required. We've done a series of models on establishing whether storage can be structurally safe. So will cycling temperature in the flooded mine shaft cause any problem with the mine shaft lining? Most modern mines shafts were lined with concrete, older ones were lined with brick or even wood. We have collected an enormous amount of data on the water quality from the Monckton Hall shaft and the Barony shaft. We're interested in trying to forecast what will happen to that water as we heat it up and cool it down, both in terms of potentially releasing gas from the water or creating any scaling problems on the infrastructure that you put on in the water body. We've also looked at energy systems models. As Vanessa said earlier, you need to understand what your energy demand is, whether that's heating or cooling or both, in order to understand what you're asking your store to do. So to inform what you like, if you like, the duty cycle for the energy store. And that's true whether you're looking at mineshaft storage, whether you're looking at aquifer storage, or any other form of energy storage. And then finally, we are working up detailed plans, fully costed, fully CAD designed plans for injection of heat into a real mine, but we won't be doing that during the STEAM project. If we go to the next slide, just to give you an idea of what these things look like, in the top left photograph, you can see a Google image map of the Miller Hill Energy Centre just to the top. That's the blue building at the top. That was actually opened last week. Sorry, the Miller Hill Energy from Waste plant has been going for a while, but underneath the words, the Energy Centre for the District Heat Network for the new town of Shawfair was opened last week. The area here in the kind of white box is scheduled for development for schools, primary school, secondary school, playing fields and so on. And the two red dots were the shafts that were sunk for the Monckton Hall colliery. In the bottom photograph, we've got a photograph taken down the number 2 shaft, the top dot. And the green tube is the rising main for the water treatment plant that used to exist there. And what happens when you abandon a mine shaft and you turn the pumps off is that the water levels come back up and eventually stabilise. If they come up too close to the surface water, you may get contamination with red iron oxide, and you can see in the bottom photograph, the top photograph in the bottom left, you can see an orange looking blob. That's a lagoon where the waste from the mine water treatment plant was stored, and that orange stuff is called ochre. It's not problematic, it's not particularly toxic, but it can cause scaling, and if it forms on riverbeds, it can stop fish laying eggs and things like that. But it's what the Mining Remediation Authority, sorry, they've just changed their name from the Coal Authority about 2 weeks ago. What the Mining Remediation Authority do a lot of is pumping and treating water to make sure that ochre and other undesirable compounds get into drinking water or surface water. You can go to the next slide. So these are some images of the data that we've got. We've got temperature profiles with depth in the bottom right hand corner there. You can see they're fairly stable all the way down. So unlike what Vanessa said in the rock mass where the temperature goes up, because you've got convection within this shaft, it stabilizes and it moves between different times of the year. But it's a fairly steady temperature, which is really good for heat pump efficiency. I've just been told I've got 2 minutes left, so I'm going to flick through my slides. I don't know if this is possible to do. Brilliant. If you can go to the blue slide. Keep going. Keep going. Yeah, brilliant. So these are the outcome of our research to date. Oh, need to go one up, sorry. Yeah. So what we found at Monckton Hall, and I will emphasise that every site is very unique. The water is different, the geology is different. We found that the risks are relatively low. We think we're pretty confident we'll get a permit from the Mine Remediation Authority to do an experimental heating trial. And if we can do this, then we can actually bring down the levelized cost of heat to as low as 3p per kilowatt hour if we're looking at a heat pump system, like a large heat pump system. I'll quickly skim through the next 2 projects. If you can flick again, please. One more slide. Right, the galleries to calories is the second project I want to talk about. This is being led by Townrock Energy and the University of Edinburgh. They are looking at storing energy in the mine workings rather than the mine shaft. So if you imagine the classic pictures of miners, they get in a cage, they go down underground in a big lift, that's the mine shaft. The mine workings is where they're extracting the coal, and that's what Vanessa's UK Geos site is drilled into. Galleries to Calories is a really innovative project looking at whether we can use those mine workings as a giant underground district heat network. So can we inject heat, in this case from the Edinburgh University's Advanced Computing Facility, into the mine workings, and then let the natural flow of groundwater take that heat away underneath where it's wanted and needed. And the G2C team have done a huge amount of work on building a 3D model, lots of detailed modelling. Now, I want to emphasise this is academic research. This is not what you would have to do to develop a scheme. We're doing all the stuff you don't need to do to explore the boundaries of what's safe, what's sustainable, what's effective. So if we can go on to the next slide. I also want to mention this is not academic research. This is a live project, but just to demonstrate what the capability is of aquifer storage. So rather than storing into mines, you're storing into the rock itself. If you think about the sandstone that Glasgow's built of, about 25% of that is air, the space between the sand grains. In the subsurface, that's water, and we can use that as a store, that water as a store for heat. And the SWG3 nightclub in Glasgow takes the heat out of the nightclub. They used to air condition and vent it to the air. They now inject it into the sandstone underneath the nightclub. And then the next day, when they need to heat the nightclub up before everyone arrives, they use that heat, they extract that heat back out of the ground. And they've now got 2 years worth of data. And I will say that the band that's generated them the most heat, or the nightclub event that generated the most heat, was Black Traffic Techno. So if you want to do this in a nightclub, you really need to have a lot of techno evenings rather than just, as we see here, line dancing, just simply less density of bodies. And my final slide. What does this mean? So that if you want to think about this in your community, or if you're a local authority, or if you're a landowner, you can use the heat map that Jamie showed us to establish whether you have a mine or a mine shaft below your land. Or if you're interested in aquifer storage, you would look at the British Geological Survey data to do a very first pass scan to see, do you have that, do you have the right rock types under you? You'd need to think about the energy demand at your site. Are you interested in heating, cooling, storage? And remember that if you have any form of very large scale energy storage, that can act as a service to the grid, and you can actually get money from the electricity companies to store that energy. Can you match the two? The first thing to do would be to speak to the Mining Remediation Authority or the British Geological Survey, or one of the companies like Town Rock Energy, who've developed the Body Heat project and G2C and have been helping us with steam, or even your local friendly academics to explore feasibility. On the right hand side, we've got some data from one of my PhD students who's been looking at projects that went wrong, because often we don't hear about projects that went wrong. What you can see is the biggest pie slice here is projects failing because they didn't get the geology or the hydrogeology correct when they drilled those boreholes. So it is important to invest in site characterisation, ground investigation with the right people, the British Geological Survey, Mining Remediation Authority and so on. But if you get it right, the returns can be very, very lucrative and very long term. So it's a good investment for a long term energy storage or geothermal solution. And I'll finish there. So back to Emma. Oh, sorry, no, Rachel McCall from Scottish Enterprise.
Thanks, Zoe, that was great. And all right, so hi everyone, and my name is Rachel McCall and I'm an energy transition specialist at Scottish Enterprise. So I lead geothermal energy with a focus on building the manufacturing and supply chain opportunities in Scotland. So my role is really to engage with businesses all across Scotland to really understand what are the opportunities, what are the barriers to developing geothermal in Scotland to really help decarbonise our homes and buildings. So I work very closely with the likes of Zoe, Jamie and Vanessa on the call today. Please take a note of my email on the previous slide and talk to me about any of the support I'm just going to talk about today. So as you can see from the slide, we have a range of support available in our team, and I'll just talk through these individually. Next slide, please. So the Clean Heat Expert Support Programme is open to all applications. It's a pan-Scotland service provided by Scotland Enterprise, Highlands and Islands and South of Scotland Enterprise companies who really wish to grow and move into an emerging clean heat sector. So this support is in place to help you understand whether your company capabilities are or could be made transferable to the clean heat sector. You'll gain a realistic overview of the potential benefits of diversifying into clean heat in terms of maintaining or increasing your turnover, workforce or facilities. Importantly, this is 3 days of free, so that's no cost, consultancy support that will be delivered by a consultant. The consultant's EP Consult Energies Limited. And this consultant will work very closely with you one-on-one, and then you'll get a short tailored report at the end of it, really describing your needs, the opportunities and an action list with specific areas to focus on. So please complete the application form if you are interested in this, and then the specialised team will be in touch with you just to talk you through your application to really help you get on board. Next slide, please. The next level support is the Clean Heat Strategic Workforce Development Fund. Importantly to note, to apply to this, you need to submit an expression of interest no later than the 16th of December this year. So I'll briefly go through it, and then you can visit the website and speak to our specialists if it's something that you want to pursue. And it's really in place to offer support to companies that are either already active or interested again in diversifying into the clean heat market. As part of this service, your business will receive strategic workforce development support from a specialist in our workforce innovation team, along with funds to provide support in likes of workforce capability and culture, workplace practices, leadership and management. So to expand on this, you could look at areas of technical training, such as the manufacturing of clean heat equipment and related components and enabling solutions. So thermal storage would fit in that. And also the commissioning of heat networks or equipment for heat networks. There's also support in training and enabling technology. So that would be automation, 3D printing, electrical and mechanical engineering, working with different types of materials, data, digital, funding for communication, your social media, professional selling and marketing, and then the leadership and management development as well, such as Lean Six Sigma and project management. You can get a grant between a minimum of £5,000 and a maximum of £50,000, and the project needs to be delivered by the end of March 2025, with your final claim submitted by the end of April 2025. So please visit the website to find out a little bit more and just see what the eligibility is. Next slide, please. This slide is all about European funding and support, so that in research, development and innovation. Another hat that I wear as I'm part of the Scottish European Green Energy Centre. So this team sits within the Clean Heat team, and our role is to really help you access European funding. So we'll hold your hand through the whole process, and that's through navigating different European funding calls, identifying partners both within Scotland and European, and to really help you develop that long-term relationship. And in the end, strengthen this funding application. We can review it or get the right people at the right time to help review your application, and overall help increase your overall successful application. We do use this Team Scotland approach, so we work with colleagues in the likes of Scotland Europa, Innovate UK, ETP as well, to really ensure that we get that full reach of networks to support your application. As an example of a fund that was live was the Clean Energy Partnership. that recently closed, but just gives you an idea of the type of money available. So this was £5 million pot for Scottish companies, and it was across 10 energy modules. One was geothermal. So definitely look out for something like this again next year, probably after the summer, for a similar type of funding available. But we also support Horizon Europe applications. So they are currently in draft, and I've been told probably published around springtime. And I'm aware there are 2 geothermal calls within the draft on the topic of underground thermal storage. So if you just want to have a general chat about European funding and just curious about the Horizon Europe calls or the Clean Energy Transition Partnership, please get in touch with me and we can just have a one-to-one chat to explore the opportunities further. And there is a European newsletter that posts upcoming events and also funds that are available, so please join that as well, and we'll share that with everybody afterwards. The next slide is just a general one about SE support in general. This is this goes beyond just the clean heat team. We offer support right across, we have our innovation specialists, we have our sustainability specialists. If you're looking at your IP or you want to talk about the likes of like business support, just get in touch with me and I'll pass you on to the right person. We've got a wealth of knowledge within Scottish Enterprise. And my final 2 slides, and then we'll get into Q&A, is just to make you aware of this funding from Innovate UK as part of their UK Research and Innovation. This is the SMART grant and live in November 2024, and it's for UK registered organisations to apply for a share of up to 15 million for game-changing and commercially available R&D innovations that can significantly impact the UK economy. Your project will have to be between 6 to 18 months and must have a total eligible project cost between 100,000 and 500,000 and can be single or collaborative. Projects of 19 to 24 months must have a total eligible project cost between 100,000 and 1 million. The competition is open and will close on Wednesday, the 22nd of January. There is a link on the slide just to contact Innovate UK directly to find out more. And my final slide is please join the Clean Heat community. We have a newsletter, we have the HeatSource newsletter that Emma made you aware of, and please note the 2 upcoming webinars that I'm running in January is all about procurement opportunities to help you understand how to get onto frameworks, etc. But any other questions, just please contact me directly. And that's me. I'll hand back to Emma and we'll go on to doing a poll next, I believe. Thanks.
Thanks, Rachel. Massive thanks to all of our speakers. I'd invite you all to pop your cameras back on. And just before we get into our Q&A, quick reminder, anybody on the audience can pop their questions into the chat. We've got a few to work through here. But before we do that, we'll pop that quick poll on to see which of those sort of opportunities some of our audience might be interested in exploring a little bit further. That'll just allow Rachel to support in the kind of follow-up side of things. Thank you very much. Just about another 30 seconds to pop your responses in there. And I think the important thing, the takeaway, is that particularly around those kind of larger funds, they come around on a kind of annual basis, slightly different focuses. They are quite resource intensive and do require, in-depth collaboration. So hopefully you've seen lots of ways to engage with our speakers today about how to then access and how to get involved in wider networks. Vanessa's workshop coming up, all of the research work that's going on across our universities as well. It's a fantastic community to join, and hopefully you will do so. And like I say, starting some of those conversations and making those relationships now, even slightly ahead of when opportunities arise, is not a bad method to employ. So thank you very much again to all of our speakers. We have a few questions to work through. So the first one is, are underground thermal energy systems and schemes recognised as heat networks, and have any existing schemes been included in local area energy plans that you're aware of? I think I'll put that to Vanessa, you first. Oh, pop your microphone on as well, Vanessa.
Thank you. I don't know of any examples that have necessarily been included in the local area energy plans, but really any 5th generation district heat network will have both heating and cooling. So yes, it certainly can be recognised and should be recognised as a heat network. I imagine that therefore it will be included in some of the local area energy plans, and certainly should be. And there's quite a few overseas examples that are out there. For example, Hill and Bokken are probably two of the most well-known ones. So yes, is the answer to that question.
Anything to add from you, Zoe? Thank you, Vanessa.
Yeah, I don't think they have to be heat networks. I think the Body Heat project is a really good example of one that isn't a heat network, in that it has a single producer and consumer of heat, and it's all within the one small site. But the University of Leeds, I know, are about to start constructing their energy centre based on borehole heating and cooling. So like Vanessa, I'm not sure about what's in the local area energy plans in Scotland, but certainly they are being rolled out across the UK.
Excellent. So something slightly on the more technical side, is there any limitations of mine depth, mine water temperature and volume of water for mine water thermal energy storage systems?
Not really. The limitation is more to do with you wouldn't really be wanting to do things too shallow, because the risk then that you bleed your heat out to the surface and it's not effective. One of the ideas of doing this underground is that if you do it deep enough, you don't need an insulator on top of a tank because you've got the rocks. The other reason why you wouldn't want to do it too shallow is the shallow mines are the older ones. So when we first started mining coal, we were digging out holes in the ground, and then we started mining deeper and deeper as the technology got better for pumping out that water and getting the miners down there. So the deeper mines are the more modern mines in general, and the more modern the mine, the better they were constructed, the more robustly they were constructed. There's actually a YouTube video about the Comrie mine in 1945, and it looks like going down into the tube. You go down in a lift and you come out in a big whitewashed hallway with big steel arch girders. That these are very, very well engineered structures. So the limitation is more about not doing it too shallow, and then it would be a trade-off between the capital cost of accessing that mine and the payback period in terms of how much energy you can store and how much cooling you get back. So that one of the messages I think is that every site is very, very site specific. You're not constructing a new tank like you are, with heat networks. There's one out the back of my building here for the Strathclyde Uni heat network. That's just a tank. But the BGS facilities allow you to explore what you might find at your site, but also the expertise within the BGS and the Mining Remediation Authority. There's a huge amount of expertise that will help you understand your individual site.
Fantastic. Which actually probably brings me on to my next question, one for you, Vanessa, again. What are the benefits of underground thermal energy storage over above ground thermal stores, like those commonly used for district heat networks?
So the underground thermal storage, one of the benefits is that it is actually large, which is something that's very important to think about it. So down wherever you've got above ground, you've got a certain volume because that's all you can have in the store. Whereas if you think about mines or aquifers, they're very extensive. So that is a massive benefit. And also the other benefit is that the ground itself is maintained at a constant temperature. So as we said right at the beginning with the geothermal gradient, it gets hotter as you go down. And it's that stable temperature throughout the year. So even if you've got excellent insulation, you've still got that fluctuation seasonally. If you've got anything above ground, you're going to have to be a little more careful in the colder months than you are, whereas below ground, you've got that stable temperature.
Excellent. I just want to draw attention to something that one of our attendees has made us aware of, that the Mining Remediation Authority will soon be making data available for 70 plus waste mine water heat opportunities across the UK from their existing mine water treatment schemes. So that's definitely a publication and a bit of information and data that we will be keeping an eye out for, and we will publish in the HeatSource newsletter around that. So if we can ask that attendee to make sure that they keep us on top of the scheduling of that that publication. Unfortunately, we have come to 2 o'clock. We can do 1 or 2 more questions if our panelists are happy to stay on the line, because we still do have 50 of our attendees on. We can work through, like say, a couple more questions. Any that we don't get around to, we will, like say, they will be answered in our post-event communications. Sorry, Zoe, did you want to come in on that data?
I was just going to say that the opportunity that the Mine Remediation Authority are creating there is not underground thermal storage or even geothermal heat per se. It's taking heat out of the wastewater ponds. And that there's a scheme a bit like that in Dalmarnock in Glasgow that uses the heat from a sewage treatment plant. And indeed, the super school in Cumnock is heated by heat from a wastewater treatment plant there. So it's a different opportunity. You're not really looking at the geology there. It's just enabled by the legacy of mining infrastructure.
Absolutely. Thank you so much. And we do have just a couple more questions. One from, I think for you, Jamie, is how can organisations access the kind of more detailed version of Scotland's heat maps that they might use to inform their decision making?
Yeah, so we have data sharing agreements with all the local authorities, but we have also made the data available for projects which have been commissioned by the Scottish Government, and the local authorities through that data sharing agreement can also share it for projects that they've commissioned as well. And then for other organisations, maybe academics and other researchers, there is information on the website about how they can make a request, and potentially if it's kind of aligned with the purposes of the heat map to improve energy efficiency or tackle climate change, there is a potential. But do feel free to drop the team an email if you are interested in the more detailed data, and we can, it's on a case-by-case basis, but we can work with organisations on that.
Fantastic. And there is a quick question here around asking referencing what's been done successfully in the Netherlands. That means that they've got hundreds of the schemes that are working successfully. So what can we do in the UK to accelerate our progress in making use of that resource here?
It comes down very much to the barriers that I mentioned earlier, so that they have the government. They're just a little bit further on really in the process. You know, they've got the government buy-in, they've got some policy work. So there's nothing stopping the UK in doing it. It's just we're perhaps a little bit further behind at the moment.
Excellent. Well, that's good to know. And one, Rachel, that you might be able to answer or just now or afterwards, can European SMEs participate in Innovate UK Smart Grants? One of our attendees had a bit of a check and couldn't quite immediately find the answer.
Yeah, I'll need to find that one out.
Excellent. So we will follow up with that one. And one question, are there any easier wins that we should focus to get some sort of quicker installs? Is there areas where there is, more data available where we can maybe look to get projects off the ground a little bit faster? Zoe?
I'd say really that if you're thinking about heat, and most of what we've been talking about here is heat rather than power. In fact, all of what we've been talking about is heat rather than power. You need to be close to the source of your demand. In Denmark, they've got heat networks that extend 20 or 30 kilometres, but that's really unusual. So with the opportunity with the Scotland's heat map, it gives you a really quick way of just saying, have I got a mine? Abergone Aquifer. Basically, if you're in the central belt of Scotland, you've got a really good chance of finding something that's going to be useful. If you're in the Highlands, not so much, because you've got hard rocks that are not suitable for the kinds of resources we've been talking about here. But certainly up around Aberdeen, you've got deep granites that are very suitable for deep geothermal power. And shortly into 2025, the UK will be opening its first deep geothermal power plant down in Cornwall at the United Downs project, where they've got a 5-kilometre deep pair of boreholes that are producing water hot enough to have a binary power plant. Sometimes geothermal is talked about as being anywhere, and it kind of is. You can engineer your way around most barriers, but that costs. So the cheap, easily accessible heat, really, the central belt of Scotland is ideal, and bits of places around the Moray Firth. And
yeah,
the heat map will show you that within seconds.
Mm-hmm. And maybe a question, Rachel, for you around existing companies that are maybe in that kind of drilling, pipework, engineering sort of space, from our obviously rich oil and gas exploration work in Scotland. How can they understand what the opportunity looks like for them, you know, as we might transition to more geothermal-based projects across Scotland?
Yeah, come to webinars like these, engage with Scottish Enterprise, engage with the Net Zero Technology Centre, the National Geothermal Centre up in Aberdeen. Robert Gordon University have a drilling simulator that they can work with and definitely visit and see how that can be applied to geothermal. So loads of resources and tools out there and networks that they could be engaging with. But first point of contact is all the speakers here today, and we can definitely point them in the right direction.
Fantastic. Thank you so much to all of our speakers. I think we have pushed it probably to the limits of our attendees, and we're about 5 or 6 minutes over time. It just remains for me to thank everybody for attending, to listening, and engaging with our speakers today, to speakers for sharing you know, fantastic opportunities and really highlighting the scale of ambition and activity and, you know, appetite for collaboration that there is in Scotland. We have put lots of links into the chat. Like I say, we will share them afterwards. And all that remains for me is to, you know, continue to engage with HeatSource, and we will do more of these events, raising awareness and, you know, creating opportunities to network and find out a little bit more about some of the kind of business opportunities and research opportunities going forward. So yes, thank you very much, and we'll see you at more of our events next year. Thanks again to our speakers. Goodbye.
Thank you.
Thank you very much. See
Bye.
you later.